One is on polygon. So a polygon is a plane figure that meets the following conditions. So we have to have 3 or more segments joining together that are called the sides. So they have to be straight, they're segments. Each side intersects exactly 2 other sides, one at each endpoint, and each endpoint is called a vertex. So plural, that is vertices. Have you guys all heard vertices before? So you can name a polygon by listing its vertices consecutively. For instance, you could name the polygon above in the following ways. So you could call it A, B, C, D, E. Or you could call it like D, C, B, A, E. So wherever you start, in whichever direction you go, you just want to go in that order. Does that make sense? So I could have D, E, A, B, C. Or I could have D, C, B, A, E. And so on. Okay, so we said it has to have straight sides, they have to connect to be points, so that they have to connect at vertices. So let's think about whether the following are polygons. So is A a polygon? Yes. Okay, this is what we call a concave polygon. Why do you think I call it concave? Yeah, it caves in, right? So this is, yes, it's a polygon. B, yes. C, yes. D, no. Why? Yeah, exactly. So that's not a segment, right? E? No, it doesn't connect. F?
Yes.
I would say no. So it's actually kind of like 2 polygons together, right? All right, so next one. So names of polygons. So I think you guys know the names of different polygons. So if you have 3 sides, it's a triangle. 4, do you guys know what that is? Starts with a Q. Quadrilateral. 5. Pentagon. 6. Hexagon. 7's tricky. It's a heptagon. Everybody always says septagon. It's a heptagon now. Octagon. 9 is my favorite. Nonagon. Isn't that fun? Nonagon. 10. Decagon. Good. And 12. It's 10 plus 2, so we call it dodecagon. Dodecagon. 2 plus 10, right? And then insides we just call an n-gon. Okay, so we'll revisit this. We'll be talking about these in another section as well. Trivia question. Do you guys know why September is you would think it's the 7th month, it's the 9th. October, you would think it's the 8th, it's the 10th. November, you would think it's the 9th, right? With the nonagon, November, but it's the 11th. So why are we all messed up there? Why is December our 12th month instead of the 10th month? No one knows this trivia question? All right, so in the Roman calendar only had 10 months, and then Julius Caesar and Augustus Caesar decided that they were so important that they needed months named after them, July and August, so they got snuck in there and it messed up all of our stems, all of our knob. All right, so anyway, so a convex polygon, like we said, is one where everything is going outwards. It doesn't cave in on itself. So the definition says a polygon in which no line that contains a side includes a point inside of the polygon. So if I extend these lines, it doesn't go into the polygon. But if I have a concave one, so something like this, if I extend this side, do you see how it contains points that are inside of the polygon? So that is concave. It caves in. All right, so identify the polygon and state whether it's concave or convex. So how many sides does it have? 1, 2, 3, 4. So it's called a quadrilateral. Is it convex or concave? Convex. So it's a convex quadrilateral. The next one has 1, 2, 3, 4, 5 sides. So it's a concave. And then what's the word? Pentagon. You got it. So you can name these things. An equilateral is exactly what you think. Equal sides. Lateral means side. So equal sides. A polygon with all sides congruent. And equal angular, equal angles. So a polygon with all angles congruent. A regular one is both equilateral and equal angular. So all sides and all angles are congruent. Okay, so if you hear a regular hexagon is going to be where all of the sides are the same and all of the angles are the same. That would be a regular hexagon. Does that make sense? Okay. So decide if the polygon is regular or not. So how about this one? Do we think it's regular? Are all the sides the same? Yeah? Are all the angles the same? No. So this is no. So the angles are not congruent. Do you see why they're not congruent? This is not 90, right? All right, how about the next one? Is it regular? No. Why? Right, the sides are not congruent. Perfect. So in order to be regular, you need all the sides and all the angles to be the same. All right, a diagonal of a polygon is a segment that joins two non-consecutive vertices. So if I had like a pentagon shape, its diagonal would be like right here. So this would be a diagonal, and this would be a diagonal. However, the ones I'm drawing in red here would not be diagonals. What would those be called? Yeah, they're just sides, right? It's a side and a side. So we don't call it a diagonal, it's a side. Does that make sense? So it says how many diagonals can be drawn in the polygon on the left? So if I have, let's start with this point. I'm going to use different colors here. It's a little tricky. So I'm going to do 1, 2, 3 diagonals. Now from the next vertex, I'm going to have 1, 2, 3 more. So I'm at 6 right now. But what happens as I go to this next one? How many more am I gaining now? 2, because I already had one that was drawn in, right? So I'm now at 8. And then if I go over here, let me use a different color. Oops, I clicked on green. It doesn't want me to do green. Nope, it doesn't like green today. So this one, and that's the only new one, right? So 9. Do I have any more? It looks like there's a total of 9. So 9 diagonals. And there's a formula to get that. It uses a formula that we use in algebra 2 called a combination. But we won't talk about that formula. You could count them out easily. All right, so the interior angles of a quadrilateral. So we know that the interior angles of a triangle added up, so these 3 angles added up to be 180, right? What do you guys think for a quadrilateral? Is it 180? What do you think? 360. It is 360, right? So think about the most basic kind, a square. If we have a square, all of those are 90 degrees. So it makes sense that this would be a total of 360 degrees. So the sum of the measures of the interior angles of a quadrilateral is always 360 degrees. And we'll have a formula that we'll talk about the interior angles for a hexagon, heptagon, and so on. All right, so the next one. So it says find the measures of F, G, and H. So if I have X and X, and then I have these markings that indicate this other one is also 55, I know that these all add up to be 360. So if you solve for X, I'll do the work for you. You end up getting 125. Same idea on the next one. Oh, I guess it says find the measure of F, G, and H. So you could say measure of angle F is 125. The measure of angle G is 55, and so on. All right, so let's skip the next one. So do you guys see how we would just add all these together? They would add up to be 360, and then we go from there. Same thing for this one. This is 90 degrees. So we'd have 90 plus 60 plus 150 plus 3x equals 360. And I think when you solve for that, you get x equals 20. Okay, so is that section making sense? So let's look quickly at the next one as well. So we have about 5 minutes. Might go a couple minutes over, but. All right, so section 6.2, properties of parallelograms. So a parallelogram is a special type of quadrilateral. So based on its name, parallelogram, it has opposite sides are parallel. That's the definition for a parallelogram. A quadrilateral with both pairs of opposite sides parallel to each other, okay? So it says on the grid, construct a parallelogram. Remember that they have to have the same slope in order to be parallel. And then you can use a ruler to measure all the sides, use a protractor to measure all the angles. So we're not going to do this, but if I was drawing a parallelogram, I could really draw it anywhere. I could start it here, and I could be like, oh, I'm going to go up 1, 2, 3, 4 over 1, 2, 3, 4, 5, and you have that one. Then I could say, oh, I'm going to go down 1, right 1. And then I'm going to go up the same slope that I did before. This would be a parallelogram. Oops. And I could then measure all those angles and all those side lengths and so on. Okay, so what are your predictions? So if I have a parallelogram, oh, I'm trying not to draw it like a rectangle, but what do you think is true about this side and this side? So we said that they're parallel to each other. Anything else that we think is true? They're the same length. Okay, they'll end up being the same length. Okay, what do we think about these two sides? They're also the same length, okay? What about our angles? So this angle right here, do you think it's the same as any of the other angles in this picture? It's going to be the same. It's a big obtuse angle. So let me label A, B, C, and D. Is it the same as B, C, or D? It's the same as C. And what about B and D? Do you think those are the same? Yeah. All right, so the last thing that we have about a parallelogram has to do with the diagonals. Okay, and right now you guys might think these diagonals are congruent. They look like they might be the same size. I personally think AC looks a little bit shorter than AD, or than BD. But if I draw really, let me draw it this way. Like if I draw like a diamond shape, that's also a parallelogram. Can you guys tell that this one is not the same as this one? They aren't the same length. Okay. They do bisect each other though. So this blue line is the same as this blue line down here. And this red line is the same as this red line. Okay, do you understand what I'm saying there? Okay, so those are the properties of parallelograms. There's 5 of them. You have to know these properties. Okay, so this will definitely be on your midterm. All right, so let's start with the basic. What was the definition of a parallelogram? Opposite sides are parallel. That's the definition, so we start with that. So if it's a quadrilateral is a parallelogram, then its opposite sides are, and we can use the abbreviation for parallel. So that's our first one. Okay, if a quadrilateral is a parallelogram, then its opposite sides are, what was the next one? Yeah, they're congruent to each other. So these two are the same and these two are the same. If a quadrilateral is a parallelogram, then its opposite, let's do angles, are congruent. So these two are the same as each other, and then these two are the same as each other. Okay, I didn't talk about one of these, but imagine I had, you know, as a parallelogram, this side and this side are parallel to each other. This is a transversal. What do we think about this angle and this angle? They're not alternate interior, they're consecutive interior angles or same side interior angles. And what do we say same side interiors? They add up to be what? They're supplementary. So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So that's why I told you guys that we no longer call them same side interior, we call them consecutive angles, consecutive interior angles, because of the consecutive angles in a parallelogram. And then the last one, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So this diagonal and this diagonal cut each other in half. So these two sides are the same, and these two are the same. Does that make sense? They cut each other in half. So you could answer lots of questions about parallelograms from there. So let me kind of look at some pictures here. So it says find the unknown length. So we have all of these pictures. Well, we could say lots of things here. We could say that this is also 6. We could say this is also 8. Does that make sense? We could draw all these out and we could come up with the measurements. So like with something like number 5, What could we say are equal? We could say these two are equal to each other, right? If it's a parallelogram. We could say these two are equal to each other. Does this make sense how it works? Angles, this one and this one are supplementary. So they add to 180. And then we would go from there. Okay? All right, so we'll stop there.